right, so this is going on page 67 when we're done. And some of this we talked about quickly in October, but again, some of it is new stuff that we need to start wrapping our minds around. So I believe we talked about angles in the coordinate plane. So if I have an angle in the coordinate plane in standard form or standard position, that happens when the vertex is on the origin. So my vertex is right here. And one ray lies on the positive x-axis. So that's the positive x-axis right there. That's one side of my angle. Then that ray that's on the x-axis is called the initial side, because it's where we start. Okay, start at the initial side. And then it opens up from there. So when we start here, we're starting at 0 degrees. And then, so if it's closed, then it opens up. And this is where this one stops. The other ray is called the terminal side, because that's where it terminates. Okay, so you have an initial side and a terminal side. Vocabulary is important. And then I know that, unfortunately, the great majority of you do not know how to read an analog clock, even though there is one on the wall. But hopefully you at least know the difference between clockwise and counterclockwise, because that is important. So if I'm here and I opened up this way, which is counterclockwise, that gives me a positive angle measure. Okay. If I was to start here and rotate clockwise, that results in negative angle measures. And I think at this point you know that negative angles exist. You haven't done much at all with them, or maybe nothing, because a negative angle in a polygon doesn't make any sense. Like that, you haven't really had an application to it yet. But you'll get real used to them real quick. Okay? So let's talk about measuring angles. So the most common unit of measure for an angle is the degree. That's no shock. That's all you knew existed for quite a while. That's a little degree sign in the parentheses there. And so, if we start here at 0, and I go all the way around the circle, that is 360 degrees. So a degree, or 1 degree, is equivalent to 1/360th of a full rotation. Okay, and then we need to back up a second because I forgot to say something and label something up here. Because we're starting at 0 here, when your quadrant numbers may not have made a whole lot of sense to you when you first learned them, like why the heck are we doing that? But we start here at 0, and then they're numbered in the order you go through them. We rotate through quadrant 1, quadrant 2, 3, and 4. And we have to know which quadrant is which, and we cannot get that mixed up, because that's something that we use like a lot. All right, so we are going to graph some angles. We're going to sketch the angles in standard form with the given measure. We're not getting out protractors and making them perfect. We're just doing our best to make this make sense. So I know that my initial side has to be right here. And then that's a positive 135, so I'm going to open up counterclockwise. If I go from here to here, that is 90 degrees. I'm going to subtract 90 from this so I know how much farther I need to go. So what's 135 minus 90? 45. So each quadrant is 90 degrees, so 45 is halfway, so we're just going to do our best to aim for halfway, like so. And then that's not enough. We have to show that arrow with our direction of rotation. This is 135 degrees. Okay? Everybody good with that? Not that bad. Okay. Then we have 495. So you probably haven't dealt with angles that are that big either, because a 495 degree angle in a triangle doesn't make any sense. But you can have an angle can be literally anything. So I'm going to start here. If I rotate all the way around to here, that's 360 degrees. So I'm going to subtract 360 to figure out how much farther I need to go. What's 495 minus 360? 135. So I know what that looks like because we just did that, right? But these are not the same angle. They land in the same spot. If you think about like a hand on a clock going around, it's going to land in the same spot, but I got to show that it's different. So we started here, we rotated around and ended up there. That's why that little arrow is so important. It tells you which direction you're going and how much. And this is 495 degrees. Okay? Everybody good with that? All right, so then I have a negative 140. So I'm going to start here. Since it's negative, I'm going to rotate clockwise. So from here to here would be a negative 90. I'm going to add 90 to that. How much farther would I have to go? 50. So 50 is really close to 45, so we can just aim for halfway again, because again, it's not going to be perfect even if we try. Close enough there. Show that we went that direction, and that's a negative 140 degrees. Okay? Any questions about that? We good? All right, that's pretty simple, I think. Okay, so let's talk about radians, because radians you were introduced to in geometry, because a radian is a unit of angle measure based on arc length. Okay, so that's where you tie it into in geometry. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Here's what that means. This is the radius, and this is the radius, right? The radius is the same all the time. If I take whatever that length is and bend it around my circle, then this angle right here is 1 radian. It's a 50-something degrees. It doesn't matter what it is because you don't need to know it. It's just, 50-something degrees. And I'm going to show you this little animation that I think I showed you before, but this will help talk about it a little bit better. But we're going to draw a circle. There's our radius. So we're going to take that radius, just like I showed you. We're going to take it and bend it around the circle. And that makes 1 radian. Okay, just a different way to measure it. And then we're going to take that radian and we're going to repeat it around the circle. So to get halfway, it goes 3 plus a little bit. Well, that little bit makes it 3.14159 is pi. So then if I keep going all the way around, it's 2 pi. All right? And hopefully you did some sort of activity that you discovered that and you understood that from geometry. But and on the PSAT and SAT formula chart, it does tell you 360 degrees is 2 pi radians. That is something you need to know. It's not going to be on any other formula chart, you have. But it says 360 degrees equals, so it equals 2 pi radians. And it says, recall that the circumference of a circle is 2 pi r. It's all related to each other. And so if 360 is 2 pi, then 180 is pi. And something I think kind of nice about radians is that even though we wrote basically the units there like radians, and units are important. If I have degrees, I need my degree symbol. If it's feet, I got to put feet. Meters, miles, whatever. But for radians, we usually don't put units. It's just the nature of what a radian is. And we'll talk about that a little bit more after we understand it all a little bit more. It's okay if you don't get that part just yet. But we need to be able to convert from degrees to radians and radians to degrees. We don't do it a ton. If it's going to be on the AP test, you're going to do it like once. But overall, you need to understand the concept. But then, like I said, we don't use it a whole bunch. If I want radians, excuse me, I take my degrees and I multiply it by pi over 180 because that's the ratio there. If I want degrees, I take my radians, multiply by 180 over pi. It's not hard to remember what to do. If I need radians, I need to multiply the pi in. If I'm trying to get rid of radians, I got to divide the pi out. So it's pretty easy to remember which way to do it. All right, so we're going to convert these, and we are going to state which quadrant we're in. So I'm going to make just a little thing right here just so we can kind of point to it. If I have 60 degrees, this is 0. What quadrant is 60 in? Quadrant 1, okay? We're in quadrant 1. So I'm going to take this 60 degrees, and I'm going to multiply it, because I want radians, I'm going to over 180. So then I'm going to reduce before I multiply. I can knock the zeros out. How many times does 6 go into 18? 3. So is my answer 3 pi? No, it's not. Can you see somebody making that mistake? That's a common mistake because when it's simple, again, you fly through it, right? So don't do anything weird. It is not 3 pi. It is pi over 3 or pi thirds. Okay, so 60 degrees is pi thirds radian. All right, so 160 degrees. What quadrant do you think that would be in? 2. Good, because it's before 180. So we're in quadrant 2. So we're going to take this 160, We're going to multiply it by pi over 180. Again, I can knock out my zeros. It's nice when we can do that, which they're not disappearing. I'm dividing by 10. I think hopefully we understand that. And then I have 16 and 18. They're both divisible by 2. So I can make that 8 pi over 9. And notice that it's 8 pi ninths. It is not 8 ninths times pi, and it's not 1/3 times pi. It's always, always all in one fraction. Okay? Any questions at this point? All right, what quadrant do we think negative 330 would be in? Quadrant 1, because I'm here. Negative means I'm going this way, right? So I go all the way around. This would be 360, so negative 330 would have to be in there. So I think we're back in quadrant 1. So negative 330 times pi over 180. Knock out my zeros. And then what are 33 and 18 both divisible by? 3. So I'm going to get negative 11 pi over 6. Okay. Any questions at all? All right, so very quickly over this next week, we are going to be done talking about degrees. And everything we're doing is in radians, okay? And that's not nearly as terrible as it may sound to you right now. I'm going to make you a believer as to why radians are actually better than degrees. You may or may not leave here today a believer, but that's okay. And I'm going to ease you into this stuff, okay? I do little baby steps along the way, and there's a reason I do each little thing to kind of get us into that. But I'm going to start by pushing you out of your comfort zone and start making you think about radians, even though I know that you are not super comfortable with them, and they don't make 100% sense to you yet. I get that, okay? I don't expect them to. It's okay. Especially on these next 3, if you can just kind of hang on with me and go, okay, what you're doing makes sense. Okay, that makes sense. Then we'll be fine, because we're going to do some more on the back, and then after we do that, I think you'll feel a whole lot more comfortable with it, all right? But in that, I'm going to write more than I usually do, because I was really thinking about, like, why some students at the beginning, I'm not able to, like, you on certain things, and I think it's because I was saying things and pointing and wasn't writing it. Well, then when I made that epiphany, I realized you don't have a whole lot of room down at the bottom down there, and I have a lot of room down at the bottom. So you might want to, we'll just kind of make it work. Maybe you use your margins. I don't know. I'm sorry you don't have more room. But I do think that writing some of this stuff down as we go through these questions might help. So we're going to start by looking at just talking, and you can cram some of it up here. I'm going to do it down here just so it's bigger. But let's just talk about radians in general. I'm here at 0. If I go all the way around, that gets me to 2 pi. Right? Do we all understand? Okay, so that means 80 is what? Pi, right? Yes, we all get that. Okay, so then what do you think 90 would be? Okay, half pi, or it's fine, but it's pi over 2 or pi halves. Okay. So the key to understanding these radians on this circle is being able to think fractionally. And I know by using that word, I've already just jolted your anxiety, but it's not fractionally the way you think about fractions. I promise you it's going to make your fractions easier. What I mean by that is this. Because we're just talking about these 4, we're going to talk about these 4 angles here, the fractions we're going to use are halves. So I know that each 90-degree rotation is pi halves. Do we agree with that? Okay. So from here to here, it's 1 pi halves. Yes? So then when I get to here, that makes this 2 pi halves. You agree with that? I'm going to write it like that because we're going to say it. We're going to write some stuff here that we're not necessarily going to write a whole bunch. This reduces to pi. If I asked you what it was, your answer is pi. But when we're thinking fractionally, I'm thinking about it as 2 pi halves. You with me on that? So I have 1 pi half, 2 pi halves. What would this be? 3 pi halves. See how easy that made that? And then if I go one more, that would make this 4 pi halves. And 4 pi halves is just 2 pi. So when thinking fractionally, bless you, that's what I mean by thinking fractionally, okay? So that's going to help us. So here's where I'm going to push you out of your comfort zone. Before we convert to degrees, we're going to figure out what quadrant these angles are in, but you have no concept of how you even think about those angles right now, and that's okay. I'm never going to expect you to just know what the degrees are for 5 pi 18ths or any of those, or any angles but like 3 or maybe 4, which we'll talk about in a minute. If you need to know them, you can do the conversions we're doing. But we should know what quadrant we're in, okay? So this is how this is going to work. I'm going to make another little thing here. And my fraction, this is 5 pi over 18. So my denominator is 18. I'm going to think in 18ths, okay? So I'm here at 0. When I get to pi in 18ths would be 18 pi over 18. Would you agree with that? Okay, see how easy that is? 18 pi over 18. So what would 90 be in 18ths? 9 pi over 18. Does that concept make sense? You see how we just took half of it? 18 pi over 18, so that's 9 pi over 18. So knowing that much, what quadrant is 5 pi over 18 in? The first. See how easy that is? Oh. And again, if you're thinking, okay, I kind of get what you said, I'm not 100% sold on it yet, and I'm not sure if I could do it myself yet, that's okay, as long as you can kind of follow along right now. Or we all at least at the we can sort of follow along part. Okay, so then let's go ahead and convert. And if we're wrong, and once we get the degrees and they make more sense, we can change it. So I'm going to take my 5 pi over 18. This is radians, and I want degrees, so I'm going to multiply it by 180 over pi to get the pi out of it. The pi's cancel out. How many times does 18 go into 180? 10. And then I'm just multiplying 5 times 10, and that's 50 degrees. And 50 degrees is in the first quadrant, so I'm feeling good about that. Okay, we okay with that so far? What questions do you have? Okay, so let's look at 8. 8 is negative, so we're going to go the other way, but we'll be okay, I promise. So here's 0. So negative means I'm going in this direction. So when I get to this, this will be negative pi, but I'm looking at ninths, so this is negative 9 pi over 9. Right? So if this is negative 9 pi over 9, where do you think negative 11 pi over 9 would be? In the second quadrant, right? Because it would take me 9 steps to get over here. So I think we're in quadrant 2. So I'm going to do negative 11 pi over 9 times 180 over pi. Cancel my pi's out. How many times does 9 go into 180? 20. So now I have negative 11 times 20, which is going to be negative 220 degrees. Then I can check myself. Here I am at 0. This would be negative 180, and then I'd have to go another 40, and I'd be in the second quadrant. Okay. Any questions at all? All right. All right, 7 pi thirds. Okay, so now we're thinking in thirds. Here at 0. So what would I label this as? What do you think? Well, it's pi, but what would I actually write for this? 3 pi thirds. Good. 3 pi thirds. Okay. And again, when we actually do this, we won't be writing this every time. If you need to, you can, but we're just going to be more thinking it. But I think you need to see it the first time so you understand what I'm trying to say. All right, so I got to get to 7 pi thirds. So this is 3 pi thirds. If I keep going and get to here, what would I be at? 6 pi thirds. So if I got to get to 7 pi thirds, think of them as things. Where would I end up? First quadrant, right? So 6 pi thirds, or 7 pi thirds, I believe I am back in the first quadrant. So I'm going to take 7 pi thirds, multiply it by 180 over pi. My pi's cancel out. 3 goes into 3 once. How many times does 3 go into 180? 60, good. So I have 7 times 60, which is 420 degrees. So let's think about that. I'm here, this gives me 360, and then another 60, and I'm in the first quadrant, okay? So that wasn't that bad, right? You're going to be okay. But again, I'm going to baby step you through it, but you can't resist me at any point, and you can't not practice it, because I'm just going to keep adding more stuff to it. All right, flip it over. Let's talk about, well, actually, before we flip it over, because I think I forgot to say something up here, which is not that big of a deal, but we're going to talk about coterminal angles. I don't think I used that term when we were here, because these land in the same spot, but they have totally different values, right? If we were going to run around the track and we all started here, y'all would probably make it here by the time I got there, and then I'll just take credit for running as far as you did. But you would have run a whole lot farther, right? But they're called coterminal angles because they terminate at the same spot. So that's what we're going to talk about in the back here. Okay. So, like I said, we've got, if I start here, I can go a positive and get here, or in. There are an infinite amount of coterminal angles with this angle, because I can just keep making laps around the circle. Right? So which means for degrees, I just keep adding 360 or subtracting 360 if I'm going the other way. Think about the track that's out there, it's 400 meters for one lap. So no matter where you start, every time to count another lap, you're adding 400 meters every time, right? So same idea here. So but what our directions say is find an angle theta, coterminal to the given angle, where theta is between 0 and 360, or, and then it says 0 and pi, but that should say 2 pi, something I keep forgetting to change. So I can't just find any coterminal angle, because there are an infinite amount of answers. I need one that's between 0 and 360. Well, 544 is already more than 360. I don't know exactly where it is. I could figure it out, but I don't really care. I know it's more than 360, so I'm not going to be adding 360. I'm going to subtract 360. Okay, go the other direction. And then I would get that theta is 184 degrees. So that means that 184 would be right here, right? So this is 184. If I go one more lap, that gives me 544. I just spot. We good on that? All right, so then negative 170. Well, negative 170, I know would end me up right about there. I need the positive version of that. So I'm going to add 360 this time. And when I do that, I'm going to get that theta is 190 degrees. Which should make sense, because if I go a negative 170, I got 10 left over, right? So if I go 180 plus another 10, that gives me the 190. I just end up in the same spot. That's all the coterminal part of that means. So with the radians, it's the same idea. We're just adding and subtracting 2 pi instead of 360. And we can do this fractionally so that it makes sense for what we're doing. So I've got this 11 pi halves. And my answer needs to be between 0 and 2 pi. So is 11 pi halves more than 2 pi? Yes. All right, which means I'm going to need to subtract 2 pi. But I don't want to just put 2 pi. 2 pi as a, oops, I'm going to subtract. So as a half, it would be what over 2? What would I put over 2 to get 2 pi? 4 pi. So 4 pi halves is what I'm going to subtract so that my fractions match, right? So when I subtract those, that's going to give 7 pi halves. Is 7 pi halves between 0 and 2 pi? What is 7 divided by 2? 3.5, right? So it's not, which means I got to do it again. I'm going to subtract 4 pi halves again. Then that's going to give me that theta is 3 pi halves. So let's look at what all this mess means. This original number and the one that we got in the middle and the one that we actually wanted are all coded. So here's 3 pi halves. This is 7 pi halves. This is 11 pi halves. 15 pi halves, 19 pi halves, and so forth and so on. Does that make sense? Okay. Then we have negative 5 pi halves, which means here we're going to add 4 pi halves, which will give me negative pi halves, which is not between 0 and 2 pi. So I got to add 4 pi halves again. Oh, and look what I get. 3 pi halves again. Because when I look at these, they're all the same also. This is negative pi halves, negative 5 pi halves, pi halves. I end up in the same spot for all of them. Okay? Any questions at all? All right. We are not doing 14 through 16 because we don't need to. But reference angles are huge for us. They're going to make once we understand what they are and how to find them, they make your life so much easier because there's so much stuff we have to know and be able to figure out. It narrows it down to us only having to know a little bit and then knowing how to apply it to everything else, okay? So a reference angle, for an angle theta in standard form or standard position, the reference angle is the positive acute angle, always positive, always acute. Positive acute angle formed by the terminal side in the x-axis, not the y-axis. Okay? So here's what all this means. So here's theta like we graphed on the front. Okay? We figured out we could graph these. Pretty good at them, right? There's theta. So what I want is not necessarily, I'm going to have to graph theta, but I'm also going to have to find the reference angle. So I take the terminal side and the shortest way to the x-axis, and that is my reference angle. We're going to call theta all the time. A reference angle is traditionally referred to as alpha. I mean, you could refer to it as something else. It's not like a rule, but that's kind of what happens. Jesus fish, like this, to the wall or something. So it's A, but it's got that weird tail on it. So we're just, again, going to do the best we can to be able to write things. And this is our reference angle. So after we find some of those, I will explain to you why they're important to us, but let's just figure out how to find them first. So let's graph 150. I'm going to start here. This gets me to 90, right? How much farther do I have to go after 90? Is it halfway? What's 150 minus 90? 60. So it's more than halfway. It's like 2/3 of the way. So we're going to aim for 2/3 the best we can. Halfway would be 45. All right, so this right here, this is theta, and it is 150 degrees. Okay? Our reference angle, I take the terminal side and the shortest way to the x-axis. This is my alpha. And what would that measure have to be? 30, right? Because we would give me to 180. Okay. Everybody okay with that? All right. Let's try 315. I'm going to start here. 360 would get me all the way around, but I'm not quite to 360. So how much farther would I have to go? What's 360 minus 315? 45. So I would have to, I'd have to back up 45, which is halfway. So I'm going to aim for halfway there. And then this is theta, which is 315 degrees. Okay? Everybody okay on getting that? So then my reference angle, my terminal side and the shortest way to the x-axis, this is alpha. What's the measure of alpha? 45. Like we figured that out to be able to graph it, right? It's not going to be difficult to find. Everybody okay with that? All right, so now I have a negative 240. I'm going to start here. It's negative, so I've got to go clockwise. Get to here, that's negative 180. How much farther would I have to go? 40 minus 180? 60. It's 60. It is 60. And so that's okay, because us not being able to subtract these right now, I'm totally going to make y'all believers in radians in just a minute. So this right here, this is a negative 240. So theta, negative 240 degrees. Then my reference angle, terminal side, and the x-axis. This is alpha. What is alpha? We just said it. We did, you're right. We did just say 30, but it wasn't right. But that's okay. 60. It's all good, man. See, the more y'all get these wrong, the more I'm going to make you a believer in just a minute. All right. So are we all good so far? Okay. So now we're all good except for the subtraction, right? It's all good. It's fine. We are going to graph these radians, but we are not going to convert them. We're going to do it with what we understand, the little bit we understand about radians right now. We can do this. Now, when I said we're going to be 100% radians, no degrees at all, I mean, that's the truth, but I do think that knowing a couple of the angle measures and how they relate helps you visualize things and makes it make more sense. It will definitely help us know where to aim when we're trying to ballpark our stuff here. So the three angles that you need to know, and I mean, yes, commit to memory, but that doesn't mean necessarily memorize. It's going to almost be hard for you not to know. But I want you to write these down. You need to know that 30 degrees is pi sixths radians. 45 degrees is pi fourths radians. And 60 degrees is pi thirds radians. Okay? That, and then also that pi halves is 90. Knowing those, then everything else is going to fall into place. We become experts on this stuff. So before we muddle it with anything else with radians, I want you to look at these numbers and look at 30 degrees goes with pi sixths and 60 goes with pi thirds. Okay? The sixes don't go together and the threes don't go together, right? So keep those in mind. And then 45 is pi fourths. Again, committing these to memory is not going to be that big of a deal, although sometimes people get these mixed up. That's why I want you to kind of look now and see how all that works. Okay, so let's get our 5 pi thirds graphed. And we're going to think fractionally again, right? But we're not going to necessarily write as much as we're not going to write as much as we did before, because hopefully we don't need to, but we're going to start here. Okay. And what we were writing on the front, as I rotate around, if I'm thinking in thirds, right, because it's 5 pi thirds, this would be 3 pi thirds. You agree with that? And then what would this be? 6 pi thirds, but I only want 5 of them, so I'm going to back up pi thirds, right? What is pi thirds in degrees? 60. So that's going to help me where I aim. So if I back up 60 degrees, I back up about 2/3 of the way, kind of right there. So this angle right here is 5 pi thirds. This is theta, okay? 5 pi thirds. This is my reference angle. What do you think alpha is? Pi thirds, right? Because that 5 pi thirds, I need one more pi thirds to get me to 6. Think of them as things, because that's really all fractions are. Easy enough? Now, remember when we did these special right triangles yesterday, and I said eventually, not now, and not today either, you're going to have to be able to tell me what's the sine of pi thirds, what's the cosine of pi thirds. You're also going to have to know the sine, cosine, everything of 5 pi thirds. But you only really have to know pi thirds, because we will refer to this as a fourth quadrant pi thirds angle. If you know everything there is to know about pi thirds, you already know everything you need to know about 5 pi thirds. So it's not only about the reference angle. The reason this angle is also important is because we have to know what quadrant we landed in. So this is a fourth quadrant pi thirds angle, and that's going to tell us a lot to be able for us to get to where we need to be. Okay, we good on that? All right, let's try this 13 pi sixths. So I'm starting here. So I'm here. When I get to pi, I would call that what? 6 pi sixths. This, when I get to here, is what? 12 pi sixths. I need 13, so I got to go one more, right? What is pi sixths in degrees? 30. So that means I'm going to go 30 right there, and that's what this looks like right here. So theta is 13 pi sixths. You need to know that pi sixths is 30. I don't care if you know what 13 pi sixths is in degrees. Nobody's ever going to ask you. And if they do, it's going to be a question where you can use the conversion formula, right? Those are not things we have to commit to memory. All right, so then I need my reference angle. So this here, that's my alpha. And what do you think that is? Pi sixths. We good on that? Ask me a question if you got a question. Okie dokie. Now we got a negative. We're going to start here. I got to go clockwise now. So this is going to be negative what? 4 pi fourths, right? If I'm going this way, negative 4 pi fourths. I need to go one more to get to negative 5 pi fourths, right? What is pi fourths in degrees? 45, so we're going halfway there. So this is theta, and it is negative 5 pi fourths. Reference angle is right here, and what do we think that is? Pi fourths, you got it. All right, now let me see if I can make you believers, at least get you. This is my the beginning of my indoctrination of getting me to believe. When we look at these these reference angles that, and trust me, y'all weren't the only ones that were struggling with subtraction. Y'all were just funny about it. But when I had to find these reference angles, we had to actually subtract, right? Which clearly wasn't too easy for us. Our brains weren't working, and that's okay. But I had to like literally do math and figure that out. Okay. Here on these three, I was really just counting, and I didn't have to, even though it's fractions, it was easier. Not only that, but before we graphed anything, I could have told you what the reference angles are, because look at how they're related. Negative 5 pi fourths, pi fourths, pi sixths, pi sixths, pi thirds, pi thirds. The only three reference angles you're going to care about is pi thirds, pi fourths, pi sixths. And you're going to know exactly what your reference angle is by looking at whatever the denominator is, okay? Now, again, there's another layer to that. Like, we still need to know what quadrant that's going to land in. So this angle is a second quadrant pi fourths angle. This one is a first quadrant pi sixth angle. And I know that doesn't mean anything to you right now, but it will. So as long as we can find them and you see the relations, you're not going to have to be adding and subtracting because the degrees could be all over the place. With the fractions, we're basically just counting fractionally, and it's really pretty simple, okay? Do you have any questions at this point? All right, so now we've talked a lot about quadrants, and we still will. What quadrant is 90 degrees in? It's not in a quadrant, is it? 90 is right here. So it's like between them, right? So when you look at that, that's not a trick question. You might be asked that question, but that's what this is talking about. When the terminal side of an angle that is in standard position lies on the x or y axis, it's called a quadrantal angle. So if we are at 0, like the angle hasn't even opened, or you're at 2 pi or whatever, that's on the axis, that's a quadrantal angle. Your pi halves, it's not in a quadrant, it's a quadrantal angle. Now, it does help to know not just the quadrantal, but it's quadrantal on the positive y-axis. This pi is quadrantal on the negative x-axis, and 3 pi halves is a quadrantal on the negative y-axis. Like, you still need to know where it is because that's going to matter, but it's not in a quadrant. Okay? What questions do you have? We good? All right, so your assignment is on a worksheet. I highly, highly suggest that you practice on this today because we are going to move on a little bit more tomorrow. We're going to do a cool activity, so make sure you come back for all the fun.